Hey everyone, welcome to my channel. In this video, we'll explore Terraform meta-arguments and how they make your infrastructure management a lot easier. We'll begin by understanding what these meta-arguments are and how they play a crucial role in your Terraform setups. These are special arguments that allows you to manage your resource dependencies, scale your resources, and manage lifecycle of the resources that you're going to manage. We'll start with count, then we'll dive into for each. After that, we're going to look into provider argument, which allows you to customize the configuration for your resources so that you can deploy resources in different environments or regions. Following that, we're going to look at depends on, and at last we will discuss lifecycle argument, which allows you to manage essentially the life cycle of the resources, like how they're created, updated, and deleted. Throughout the video, I'll demonstrate each meta argument with practical examples showing you how you could apply them effectively in your setups. By the end of this video, you'll have a strong understanding of what meta arguments are and how you can use them within your Terraform projects to create more efficient and reliable configuration. So let's get started. We'll start with understanding what meta-arguments are and why they are super useful. Meta-arguments in Terraform are special arguments that can be used with any resource type to change their behavior or to make them more dynamic. They provide additional functionality and control over how Terraform manages your resources. They help you manage things like lifecycle of your resources and handle dependencies. Terraform gives us several common meta arguments to play with, which include count, for each, provider, depends on, and lifecycle. Each one has its own unique use case and can make your infrastructure setup much more smoother. Now let's break them down one by one. By default, a resource block sets up a single infrastructure object, but if you want to create multiple instances of a resource, you can use the count meta argument. Just by specifying the number, you can quickly duplicate resources without writing the same code again and again. This is especially handy for scaling your resources up or down. Plus, you get to use this argument with any module or with any resource type. When you use count, you get access to a special object called count, and this object has one key attribute, count.index. Count.index provides you a unique index number for each instance that the resource block is creating, and this number starts from 0. In simple terms, Terraform loops from 0 to count minus 1, the number you provided, and create multiple resources and assign a unique count.index for each one. In this example, we are using count meta argument, which is set to 3. This is going to create 3 instances of our web server, and each instance would be tagged with a unique index 0, 1, and 2, which can be used to kind of customize each instance. Especially their names would be like web server 1, web server 0, and web server 2. They're getting the numeric values from the count.index. When referencing instances that are created with count, you use the index number again. Again, that starts from 0. Here in this example, when we want to output IP of one of the instances, we are using the index number. Here we are using 0 to output the IP of one of the instances that was created by the resource block. All right, let's see how count works in our configurations. For this, I have a relatively simple setup. I've defined my provider's configuration in providers.tf, and the resources and outputs are being defined in main.tf file. Starting from the top, I have a single resource block. It's creating EC2 instance, and I've provided the instance type and the AMI ID. I'm using the count meta argument. This is where the magic is gonna happen. It's gonna create 3 different EC2 instances for me using this configuration, but some of the properties gonna be different, like IP addresses and DNS name, and that is kind of obvious. So we're gonna use count.index, which is an object of count meta argument, and we're gonna name the servers differently, and the count.index value starts from 0 to count -1, which would be 2 in our case. So their values would be 0, 1, and 2. Then we have outputs. Outputs are referencing to each EC2 instance that get created and display their public IP address. Now let's deploy this in our environment and see how it works. As you could see it in the Terraform summary, that is going to create the 3 resources for us. Again, going back to our configuration, we have only declared 1 resource block. The reason that again Terraform is creating 3 resources is because of this meta argument. Okay, so our 3 EC2 instances have been created and each have a different IP address. Again, going back to our configuration, the outputs were referenced using index number, which started from 0 to all the way to 2 in our case. And this is how you reference the different resources or instances that get created by the resource block, because it has created 3 resources. If I want to reference each of them, I would have to call them using their index number. Another powerful way to create multiple resource instances is by using for each meta argument. It works by accepting either a map or a set of string as its value. Terraform then iterates through that collection again, which is a map or set of string, and creates a resource instance for each element within that collection. For each is especially useful when you need to create resources based on a dynamic set of values. When you use for each, you get access to additional each object with the 2 attributes, each.key and each.value. During resource creation, Terraform loops through this for each collection. For a map, each.key refers to the key in the map, and each.value refers to the value associated with that key. For a set, both each.key and each.value refers to a member of a set. In this example, for each is going to create 3 EC2 instances for us, each with the unique name, and that get their value from the set. This is kind of how for each can be used to create multiple resources based on the values provided using a map or a set. Like count, for each can be used with any resource type or module. Just remember that its value must be known before resource block uses it. We're gonna see that in action in the demo very shortly. When it comes to referencing instances created with for each, they can be identified by the map key or a set member used in the for each value. Here we are using database key to reference public DNS of one of the instances that was created by the resource block above, which is using for each to create multiple instances. Now we're gonna see how for each works in our configuration. As I said before, for each has to have a value defined before you could use it. In here, I have a map defined for one of the resource block, and for the second resource block, I have set of string defined. First, we'll look at the first resource block. I have a map where I'm using web server, and which is gonna use as their names, and I've defined their types. So I'm gonna use the each object and then their respective attributes. If I use each.value for the first iteration, when it happens, it's gonna refer to T2 micro, and each key would have web server as its value. So in the first iteration, my server would be named web server, and it would have T2 micro as its type. For set of strings, where each.key and each.value, as I said before, have refers to same thing within the set. Here I have for each defined, and their value is gonna get used to name the EC2 instances, and where I'm using each object and the key attribute. Below, we have outputs defined, and which is kind of only suggesting how you access different EC2 instance that get created using for each. And we have to define the key name to access those resources attributes. Here in this value, I'm referring to app1, which is the resource block which is using to map, and I'm referencing to the IP or public DNS for the database key. And then I have another output which is referencing to app2 logical name of the resource block, and it is referencing to app server's public IP. Now we have defined it and saved our configuration. Let's do Terraform apply and see how it works. Before I confirm yes, I just want to quickly show you how those servers are distinguished differently based on the key for each instance. Here I'm using the app2, which is again the second resource block, and each of them are being distinguished based on the key value, which is again here web server and app server and database for app2 resource block. And I'm scrolling up, then I would see that other are being referenced using the key name as well. Here I'm using app1 resource block, and for each server is gonna get distinguished based on the key name within the map. Now confirm this and create all those resources. So supposingly, based on the configuration, I have three key value pairs, so I should get 3 resources created. And similarly here, I have 3 values within the set, so I would have a 3 EC2 instance created. So in total, I supposingly should have 6 instances get created. Okay, so all of my six instances have been created, and I'm displaying their public DNS and IP from different resource block. And one of them is from app2 resource block. I'm displaying the web server's IP address, and in the second app1 block, I'm displaying the DNS name of it. So yeah, so that's how for each works. Again, you have to define the value before you could iterate through that collection of values. The provider meta-arguments tells Terraform which provider configuration to use for a resource. This is handy when you're working with multiple providers, like deploying resources across different cloud providers, or even when you want to use different regions. By using provider, you could make sure that each resource uses the right provider setup. Provider settings are defined in a separate provider blocks and can include aliases for different setups, like for different regions, if you're going to use the same provider. In a resource block, you use the provider meta argument like this. You go by like provider =, provider, and the alias. If you don't specify it, Terraform's going to use the default provider for a resource. In this example, we used different provider configuration to deploy instances into different AWS regions. This is a great way to manage multi-region deployment. Now we're going to see how we could use providers meta argument to utilize different providers configuration and create our resources in different regions. For this setup, I've removed everything from providers.tf and moved to main.tf. At the top, I've defined what provider I want to use, which is AWS in our case, and then I have 2 provider block. First one is provider, which is telling which region I should deploy the resources, which is US East 1. Then I'm declared another provider block where I'm using alias argument. This is how it's gonna get distinguished from the block above, and this would also telling what region I want to deploy the resources if this provider get called to. Then I have 2 resources I'm creating. The first one is EC2 instance, and it's gonna pick provider block up here, which doesn't have alias argument, and the provider that doesn't have alias argument is default one, so I don't have to declare that. The resources would pick that by default. Then I'm creating another EC2 instance, and this time I'm using provider meta argument, and I'm telling what provider I want to use. So I'm telling provider name and then defining the alias name, which is I've defined here US-West, and that's where I want to have my resource created. And this different between the configuration of two provider block is the regions. First, it's gonna deploy the resources. The default is gonna deploy the resources in US East 1, and then US West 1 provider would deploy the resources in US West 1. Yeah, so essentially, if you want to reference different provider configuration, you have to use provider meta argument. Then I have two outputs, which would kind of essentially, once the Terraform apply completes, would kind of show you how these two instances are deployed in two different regions. So let's create these resources. While the resources are created, I just want to make you aware that the AMI IDs of the EC2 instance are always different depending on what region you select. So if you notice that the AMI IDs are different, yeah, that's how it's supposed to be. The AMI ID in the West and AMI ID in US East 1 would be different. Okay, so our two resources have been created, and I'm displaying their availability zones using the outputs, and this tells you that, wait a second, both are telling US East A1. What did I do wrong there? Oh, I was referencing to same resource, and I'll fix this real quick and then do real Terraform apply again. This time it's not going to create the resources, it's just going to refresh the state and should give me different outputs. Yeah, here. So now one of the resource did get created in US West A1, which would tell me that it is in the US West 1 region, and then you have another availability zone which is US East A1. That tells you that the resource is created in US East 1 region. So yeah, that's how you use provider meta argument. But before you use provider meta argument, you have to define different provider configurations either within the same file, or you could use providers.tf file if you want to separate your configuration. The depends on meta argument allows you to explicitly specify dependencies between the resources. This kind of ensures that the resources are created in the correct order, which is especially useful for handling complex dependencies that Terraform may not automatically detect. You should only use this when you have to, as Terraform takes care of the dependencies very well for the most part. In this example we are using depends on, and we are making sure that our database instance is created before our app server. You'll see that in action when we do the demo. Now let's demo how the depends on meta argument work. For this demo, I've have provider configuration in providers.tf file. And in the main.tf, I have two resources that I'm creating. First one is my SQL DB, and then have EC2 instance. We will be using depends on later, but I want to show you how Terraform works if you don't use depends on, and why I'm using depends on in this particular case. I'm gonna have my resources defined, and I'm gonna do Terraform apply. So you'll notice that the Terraform do a parallel execution when it creates the resources. So it would start creating both resources at the same time. Since DB takes a while to be created, my EC2 instance is gonna get created before my database is created. So that's what we're gonna see here. Yeah, so here you could see my AWS instance DevOps server has been created, and the DB server is getting created, and it will take a little while, so I'm gonna pause that for a bit. Okay, so finally after 3 minutes and 57 seconds, my DB has been created. So this time, like I said before, my EC2 instance did get created before the DB creation happened. Now, I have a requirements for whatever reason that I want to have my DB resource created before it creates the like Terraform creates my EC2 instance. So I'm going to use depends on meta argument and tells Terraform that I have a dependency on DevOps DB and it should create that first before it creates my resource. So I'm going to destroy what we have created first, and then we'll run the Terraform apply again. The destroy could potentially take a bit longer to destroy the DB instance. So I'm going to pause that for a bit until those resources get destroyed. Okay, after 5 minutes and 6 seconds, my DB has been destroyed. So both of the resources have been destroyed, and again, I've updated the depends on meta argument and telling that it should wait for that DB to be created. So let's run Terraform apply now. So again, this time Terraform's now gonna start the parallel execution of the resources creation this time. So it would create the DB first before it would attempt to create my EC2 instance above. So again, we're gonna wait for this to be created, and I'll continue the video once the DB is created. Okay, so my DB has just been created, and now Terraform has started creating the EC2 instance. EC2 instance creation is not going to take too long, so this should be completed relatively quick. So again, to reiterate, this only happened because on the depends on meta argument I've used. I've said it previously that you should only use depends on if you have to. Terraform is pretty good for taking care of the dependencies. If like a particular, like for instance, my resource relies on a security group or it needs elastic IP, it would create those resources before it creates your EC2 instance. But in some sort of a exceptional scenario where you want to declare and define your own order for resource creation, that's where you could use depends on meta argument. Next, the lifecycle meta arguments allows you to manage the lifecycle of your resources, like how they're created, updated, and destroyed. It is defined within a nested lifecycle block within a resource block, and you could use this with all resource types. Lifecycle block has 4 arguments, and each has its own use case and how they change and control the behavior of your resources. Let's go through them. First, we have create before destroy. When you set the value to true, it kind of ensures that the new resources get created before the old one is destroyed whenever you do any sort of update. This is useful for maintaining service availability during updates. In this example, if you need to update AWS instance in any way that would require replacement, Terraform's gonna create the new instance before it would destroy the old one. This again helps maintain service availability during updates. Next, we have prevent destroy argument within the lifecycle. This kind of adds a safeguard against accidental deletion. Here, the Terraform's gonna refuse any operation that would destroy the database instance. This is again crucial for protecting any sort of a critical resources like databases from accidental deletion. The next argument is ignore changes. This lets you specify the attribute that Terraform would ignore during updates. In this case, if the tags on AWS instance changes outside the Terraform, like perhaps someone updated on the console or something like that, Terraform won't try to revert those changes. This is kind of helpful when you want to manage Terraform in some aspects, but maybe not entirely. Then you have replace triggered by. This is a new argument in a lifecycle which kind of allows you to trigger resource replacement if certain attributes of other resources are changed. In this example, which kind of shows that if a specified security group changes, it will trigger a replacement for our EC2 instance. This is helpful when a resource depends on another in a way that isn't captured by like a normal Terraform dependencies management. So you would use replace triggered by in those kind of scenarios. Okay, now we're gonna explore lifecycle. This is one of my favorite meta arguments among others. So for this, I have again a single resource. We're gonna keep things simple. Providers information is in providers.tf file. We'll start with exploring the first argument that lifecycle has, which is create before destroy. So let's define that, and I'm gonna set it to true. So let's set it to default and see the default behavior of Terraform before, and see how Terraform behaves if I update any sort of a value. So what I'm going to do first, I'll create this resource. Setting create before destroy to false is kind of essentially equivalent to not declaring this at all. So we would typically use this when we want to set the value to true. So what we're going to do here, we're going to see the default behavior. So a resource has been created. I'm going to update my AMI ID to something different. So whenever we do AMI ID, what Terraform does, that Terraform would replace your resource. So, and it creates a new one. And that's what we're gonna see here too. Let's just see here quickly. Accept. Oh, in the summary, you could notice that, yeah, it's gonna create one and it also gonna destroy one resource. So the default behavior of Terraform is that whenever it does this kind of updates, it would destroy your EC2 instance or any resource first before it creates a new resource. And that's what's happening here. It's destroying your resource. Okay, so now, as you could see, my resource has been destroyed. My EC2 instance has been destroyed. And essentially, I don't have any EC2 instance up at this moment while EC2, like Terraform, is creating my new resource. So this is the drawback where I may not want to have my resources down at any time. You know, if I'm doing some sort of an update, I want to have new resource created before the old one get destroyed. And that's where create before destroy argument of lifecycle comes to rescue. So we're going to set it to true. I'm going to update the AMI ID again. And now I'll run Terraform plan again. So this, it's just gonna change the order how the resource is destroyed and created, but the resource is still gonna get destroyed and created. So this is not gonna have any sort of a control if the resource should get destroyed or not at all. It's just gonna readjust your order. So now I did the plan. I'm gonna do Terraform apply this time. As you could see, unlike previously, now it's creating the server first. So that's the process that has initiated by Terraform first. Okay, so now as you could see it, thanks to create before destroy argument, it created our EC2 instance before it destroyed it, unlike default behavior of Terraform. Okay, so now I've set the another argument prevent destroy to true. What it's going to do for me, that if I try to destroy my resource now, I would get an error message saying that it does have a prevent destroy argument enabled and it would not let me destroy the resource. So this is very useful in a scenarios where you don't want to have your critical infrastructure resources don't get deleted, and that's where you could do this argument and define this argument, and so that the resources don't have get deleted. And let's try to understand the third argument, which is ignore changes. So let me show you the default behavior of Terraform and how it works if we, before using ignore changes. So I have created this EC2 instance, and I'm gonna go to my console, to my AWS, and update the tags value. If I run Terraform apply now, since the configuration in my main.tf and what's on the console is mismatching, Terraform's gonna try to remove those tags because it's essentially doing the check with what we have in our infrastructure and telling that, hey, your resource should have one tag, but I'm seeing another tag, and if you run Terraform apply now, I'm gonna remove those tags. Maybe, in certain scenarios, especially when it comes to tags, a lot of teams update the tags all the time once the resources are created. So for to deal with this kind of scenario where on the next Terraform apply, Terraform does not remove those tags, we could use ignore changes meta, like a argument of lifecycle. So what I'll do ignore changes and define the attribute that I want to be ignored. So I'm just going to set it to tags. And if I run Terraform apply now, it's not seeing tags changes as changes. So it's going to ignore if any changes happen to the tags. To demo the last arguments of life cycles, I'm gonna create another resource as security groups. I've just quickly declared this one. I've named it just allow TLS. I picked it up from Terraform examples. Only thing I've defined my VPC ID, and now what I'm going to do, I'm gonna create this one before we could test it for our last argument. Okay, so my security group is created. So what I'm going to do, I'm going to remove print destroy argument and add the last argument. So essentially what's going to happen now that if any changes happen to my security group that I've defined below, it would trigger the replacement of our server. So to make any changes, what I'm going to do, I'm just going to maybe add additional tag to my security group and run Terraform apply. As you could see it even in the summary, that it's gonna add a new resource, change one, and destroy one. Let's just quickly see what's happening. So for change, it's only changing my updating the security group, like, of course I'm telling it to update the tags because I have this replace triggered by the security group. Any changes happen to the security group would enforce the replacement of our server. So that's what it's kind of summing up, but we'll see it below after we confirm here. You could see how Terraform takes that action. As you could see here, it's gonna destroy our resource and then recreate it, and then it makes the changes to our security group. Okay, so now the apply is completed. As you could see, first it destroyed my EC2 instance and then a modified security group. I was wrong about that. I thought it would do it at the end. And then it recreated, kind of created our EC2 instance. So any changes that would take place on security group would trigger the replacement of our resources. You may have certain scenarios, you may want to define the dependencies this way in a certain scenarios where if anything happens to a particular resource, you want to have another resource recreated. And with that, that's it with this video. Thanks for watching. I hope you liked it. If you did, please consider subscribing and liking my video. Thank you.